the illusion of close. Have you ever wondered how long it really takes to travel through our solar system? The Moon feels close, Mars feels like it's just around the corner, and Neptune, well, that sounds impossibly far, but the truth is stranger than it seems. Distances in space are so vast that even at today's speeds, journeys take months, years, sometimes decades. A spacecraft doesn't fly straight like a plane. It slingshots around planets, burns fuel at carefully timed intervals, and uses patience as its greatest tool. If it takes days just to reach our nearest neighbor, what happens when we aim for the edge of the solar system? The Moon, humanity's first step. Let's begin close to home, Earth's faithful companion, the Moon. Just 384,000 kilometers away, it feels like a stone's throw in cosmic terms. And yet, it is still farther than anyone can truly imagine driving. When Apollo 11 launched in 1969, it took about 3 days for astronauts to cross that gulf. From Earth to the Moon and back, the round trip lasted just over 8 days. The fastest journey ever achieved to the Moon, Apollo 10, made the trip in just 76 hours. It sounds quick, almost trivial by space standards. But pause for a moment, it's 3 days of continuous motion at nearly 40,000 kilometers per hour. Even the Moon, our closest neighbor, reminds us how vast space really is. If days are needed for the Moon, how many months for our nearest planet? Venus, the hidden furnace Venus, is sometimes closer to Earth than Mars, leading many to assume it would be faster to reach. And they'd be right. Sort of. The Soviet probe Venera 7, launched in 1970, took about 120 days, 4 months to reach Venus. It became the first spacecraft to land on another planet, transmitting faint signals from the scorching surface. But Venus is no easy destination. Beneath its thick atmosphere lies a world of crushing pressure and temperatures hot enough to melt lead. Dozens of spacecraft have tried to pierce its veil. Some lasted only minutes before failing. Venus may be closer in kilometers, but its mysteries are among the hardest to unravel. If Venus challenges us this much, what about our red neighbor, the planet we dream of one day walking on? Mars, the elusive red neighbor Mars, has always captivated us, the planet of canals, the god of war, and today the target for human exploration. But the distance to Mars isn't fixed. At its closest, it lies 54.6 million kilometers away. At its farthest, more than 400 million kilometers, NASA's InSight mission, launched in 2018, took about 7 months to arrive. The Curiosity rover, 8.5 months. Even with today's rockets, Mars is a journey measured not in days, but in seasons. That's months of drifting through space, with no chance of turning back. And that's just robotic missions. For humans, the challenge grows. Supplies, radiation protection, psychological endurance, all must last nearly a year just to arrive. If Mars, our neighbor, takes months, how long for the giants beyond? Jupiter, gateway to the outer worlds. Jupiter, the largest planet in the solar system, is both a destination and a gateway. In 1989, NASA launched the Galileo spacecraft. It didn't arrive until 1995, over 6 years later. Why so long? Because spacecraft don't fly straight. To save fuel, Galileo looped around Venus once and Earth twice, using gravity assists to build speed. When it finally reached Jupiter, it became our first long-term visitor to the gas giant, studying its storms, moons, and magnetic fields. Even today, modern missions like Juno, launched in 2011, took almost 5 years to arrive. Jupiter reminds us in space, gravity is both an obstacle and a tool. But what if closer isn't actually faster? That's the paradox of Mercury. Mercury, the paradox of the inner planet. You might think Mercury, the closest planet to the Sun, would be easy to reach. After all, it's just one planet inward from Earth. But the reality, Mercury is one of the hardest planets to visit. Why? Because to fall toward the Sun, a spacecraft must cancel much of Earth's orbital speed, a cosmic braking maneuver that takes years. The European-Japanese mission Bepi Colombo, launched in 2018, will take 7 years to finally orbit Mercury. It's scheduled to arrive in 2025. After looping around Earth, Venus and Mercury itself multiple times. So here's the paradox. Mercury is closer in kilometers, but harder in physics. Sometimes, the shortest distance is the longest road. If Mercury takes longer than Jupiter, what about the farthest planets of all? Saturn, Uranus, Neptune, the long haul. The journey to Saturn isn't any quicker. NASA's Cassini mission, one of the most successful planetary explorers, launched in 1997. It didn't arrive until 2004. 7 years of careful navigation and gravity assists. Farther out lies Uranus. Only one mission has ever visited. Voyager 2, launched in 1977. It arrived in 1986, nearly 9 years later. Then came Neptune, the final giant, which Voyager 2 reached in 1989, after 12 years of travel. And here's the sobering fact. Since Voyager 2, no mission has returned to Uranus or Neptune. We've had just one glimpse of these worlds, and decades later, they remain mysteries, but one spacecraft dared to go farther still, to a tiny icy world at the edge of the map. Pluto and beyond, the edge of the solar system. For decades, Pluto was the final planet, the icy frontier. When NASA launched New Horizons in 2006, it became the fastest spacecraft ever launched from Earth. Yet even at record speeds, it took 9.5 years to reach Pluto, arriving in 2015. Its flyby gave us our first close-up images: mountains of water ice, plains of frozen nitrogen, a heart-shaped glacier that captured the world's imagination. But Pluto is not the end. Beyond lies the Kuiper Belt, a region of icy worlds and comets, and beyond that, a vast emptiness leading toward the Oort cloud, a theoretical shell of frozen bodies stretching halfway to the nearest star. Voyager 1, launched in 1977, has now traveled more than 15.5 billion miles. It crossed into interstellar space in 2012. Yet even now, after nearly half a century, it has only just begun its journey into the galaxy. Conclusion: time, scale, and perspective. So how long does it really take to travel through the solar system? The Moon, days; Venus, months; Mars, seasons; Jupiter and Saturn, years; Uranus and Neptune, nearly a decade or more; Pluto, almost 10 years. Interstellar space, lifetimes. Even at our fastest speeds, the solar system remains vast beyond imagination. Each mission is a triumph, not of quick travel, but of human patience, precision, and persistence. And yet, we go. Because each new world brings new wonders. Volcanoes on Io, rings around Saturn, glaciers on Pluto. Every mission reshapes our understanding of what's possible. The distances remind us we are small, fragile voyagers on a pale blue dot, but with courage and curiosity, we have touched worlds millions, even billions of kilometers away. The solar system is not just a map of planets, it is a timeline of journeys. Journeys measured not in miles, but in years, and in the unshakable human will to explore.